Greetings from the Sub-Ether. This is Alan with another quick color basic video, this time coming to you from a remote location where I don't have any of my equipment, so you get a cell phone video. You're looking at the screen of a Raspberry Pi 400 running the latest XRoar emulator, so let's begin. Recently I posted a video about a different way of doing if, then, and. Instead of doing if a equals greater than 1 and a is less than 100, then you could do if a is greater than 1, then if a is less than 100, then, and that was substantially faster. In the comments of that video, color computer legend Aaron Wolf mentioned that it was probably because the second one short circuits the search. As soon as it finds a case that's not true, then it can stop checking and just scan the line until it finds an else command or a colon or the end of the line, whatever it is in that situation. So I thought we'd put that to a test by making a quick program, timer equals 0, for I equals 1 to 1000. And we're going to do a comparison the old-fashioned way. If a equals 1 and a equals 1 and a equals 1 and a equals 1, then rem. And how are we going to make all of those true? Line 5, a equals 1. 30, next, print, timer. So it looks like this. Let's do it this way. 1222, that's with all the cases being true. Let's set them to false by making a 0. 933, so if none of the conditions are satisfied, it's faster. Let's change that to the new way. If a equals 1, then 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 rem. And we'll set a equals 1 and we'll run this. 1222 is the time to beat. 886, so that's faster. And if none of the conditions are met, 339, substantially faster. And I believe what may be going on here is every comparison can be turned into a mathematical result. Does a equal 0? Negative 1 means it does. Does a equal 5? 0 means it does not. Negative 1 is true, 0 is false. Just like you can do bit math, and I can say, let's see, 7 and 2. Is the 2 set in that? Yes, it is, because a 7 is the bit pattern of that, and 2 is that. So it prints 2. So you can say print 7 and 2, and you'll get the result of 2. So if you print 7 and 2 and 4, you get 0 because it's taking the results of 7 and 2, which is 2, and 2 and 4, which is 0. So I think that when you have a comparison like if a is greater than 1 and a is less than 100, it's really doing something like this. A is greater than 1 is 0, a is less than 100 is negative 1, so it's doing if 0 and negative 1 then, and it's doing math. That means if you have a bunch of comparisons on a line, if a equals greater than 1 and a is less than 100 and x is greater than 5 and x is less than 6, whatever those results are, it's doing if 0 and negative 1 and negative 1 and 0 or whatever. I have not looked up in the source code to see if that's really what's going on, but that appears to be how it operates. Thus, when you do a comparison where it's doing and, it has to walk through everything because it doesn't know what's going to happen next. It seems like it could still short circuit the moment it finds a 0 when it's doing an and, because at that point, if the rest is and. However, the reason you can't is you might be doing if 0 and negative 1 and 0, or, and as soon as you do or, it has to turn that number into something else. So it has to keep scanning the line. Remember that when you've got bit patterns like, which is a value of 7, and that, which is a value of 2, you can print them together with and, 7 and 2, and it shows, 7 and 2, and it shows the ones that are both on, but if you OR them, 7 or 2, it combines those bits, so of course the top 3 are set. When you OR it with a 2, the bottom are set. So if I had a pattern like this, which is 1, 2, 4, that is a 5, and this right here, which is a 2, if you print them together like this, 5 and 2, no bits match, but I can say 5 or 2, and you get 7, which is that. It sets any bit that's 1. Anyway, I think that's what's going on. It's turning it into binary math and doing the comparison like that, pretty much. So let me know what you think in the comments. Maybe you can take time to look in Color Basic Unraveled and tell me if this theory holds water, and eventually I'll get around to it. Until next time, don't panic.